In today's lecture, we'll see the layout of a NOR gate. So first open the terminal window by pressing Ctrl Alt and T. So this is the terminal window. Type magic -t SCMOS and the name of the layout. Let's say it's NOR 3. And then wait for the two windows to open. So this is the layout window. This is the Tcon window. In order to see the squares, we have to type grid. So these are my squares. Shift Z. In order to draw the layout of a NOR gate, select the area, then type paint anvil so that the selected area gets painted with anvil. After that, the P diffusion layer, type paint pdiff. So this is my anvil layer, and over it my P diffusion layer, and below it I'll have my N diffusion layer. So I'll type, at first I'll select the area, and then I'll type paint and diff. This is my P diffusion and this is my N diffusion. Now here I'll short these two metal layer and I'll name it as ground, and here will be my VDD. Okay, so for that we need metal layers. Select the area and then type paint M1. So this is the metal one. The same selected portion I can keep here, and I'll type paint M1. After that, select the area, paint M1. So once this area has been selected, it keeps moving every time you select. So it's easy for us. Now I'll select this area. And then type paint M1. I don't need this, select it, press the middle key. Now the VDD has been shorted, the ground has been selected. Now here in the middle, type paint M1. Again paint M1 so that we can connect this portion to this portion. Then type again paint M1. You have to join these two. Select the area and type paint M1. So since this is a NOR gate, we need not short this portion to remove it, because since it's a NOR gate, the ground has to be shorted. The VDD is shorted in the case of the NAND. So select this area and type paint anvil, because only on the anvil we can put the P diffusion layer. Okay, so now select the area, then type paint M1. So now the ground has been shorted. Now put the contacts over here. It will be the P diffusion contact. So type paint PDC, and over here paint PDC, and the end diffusion contact paint end diffusion contact. So there are three end diffusion contacts, two P diffusion contacts. And next you have to place the poly. Select the area, then type paint poly for connecting the gates, the gate terminals. Paint poly. Poly has been selected. Next, zoom in, and here we have to do the labeling. Select the area and press right click on this edge and then type. Let's see what happens if I select the area and then I type label VDD. So the area has been selected, and here VDD, and over here ground. Okay, next zoom out, shift Z to zoom out. Next is my A. So I'll zoom in. I have selected this area and then I put a dot, label A, and this is my label B. This is my output, so I'll write it as label out. Okay, A, B out, VDD and ground. So everything is completed. Type save nor 3. And I have to extract or have to generate the .ext file. So type extract, and after that I have to convert it to .sim file. So type ext to sim, then ext to spice. So I have to see whether it's there or not. So you can see nor3 spice, sim file, magic file and the extract file. In order to exit, type exit. Now we will learn how to draw the layout of a NOR gate without using the commands. So certainly we will use the toolbar window of the layout. So open the terminal window, Ctrl Alt T, then type magic -t scmos NAND 4. So it should be NOR 4, since we'll design the layout of a NOR gate. Press enter. Okay. Now if I want to grid in, then I'll type G in my keyboard. Now Shift Z. Okay, this is the zoomed out window. Then go to options and then the toolbar. So here are my NVEL, PVEL and select, P-select, ND contact, PD contact, P substrate and substrate. Okay, for drawing the layout of a NOR gate, select the area and then we will not type and will directly select the N1. After that, this is too small. Okay, I have extended it. Now I can select the P diffusion. This is my P diffusion layer, N diffusion and P diffusion. So just below this I need my N diffusion layer. Let us extend it. Now to create the VDD first, so for VDD I'll select the metal layer and then middle click on it. So this is my VDD and my ground is shorted. So I'll select the area. Okay, and this is my metal. Okay, I'll short the ground. This is my extra part, so I'll omit it. Okay, so my ground has been shorted. I'll omit this part also. After this, I have to connect these two. So how will I connect? I'll connect through the metal. Okay. Now next is my poly. Select the area and select the polysilicon layer. Okay, this is the polysilicon layer. My input and output are ready. VDD ground ready. Place the contacts. Select the area and the P diffusion contact. Here also select the area and the P diffusion contact. Next is our N diffusion contact. Select the area select the area and N diffusion contact. Okay, P diffusion and diffusion contacts are done. Now the N substrate contact will be placed over here. N substrate contact. So I'll put 3 such N substrate contact. As I've told you, as much as you put the contacts, it is good for the layout. After placing the N substrate contact, next is the P substrate contact. I'll also place 3 such contacts over here. Okay, if I want to save, go to File and then Write. Let me zoom out. Okay, this is the layout of my NOR gate. Now I can go for the labeling. Label A, label B, and then the output. Then type label out. Then I have to label the VDD and ground. So similarly select a square or rectangle and right click on the left bottom. Type label VDD and let me zoom in. Label GND. This is my AB out, VDD and my ground. Clear this part. Go and save. Then type extract all, then ext to sim and ext to spice. So you can see the NOR git, NOR ext, NOR magic file, sim file and the spice file. Okay, now I can quit or I can exit. If you want to see the spice file of the NOR gate, then open the terminal window by pressing Ctrl Alt T, then type vi NOR 3 dot spice vi NOR 4 dot spice. Okay, so this is a spice file created from nor4.ext. So from nor, at first we had created the extraction file.ext, then we had converted to sim file, and then we had converted to spice file. So it is written here spice3 file has been created from nor3.ext technology SCMOS. So the scale is 1 micron. Here it is written M1000 A, then N to 7, VDD, the W, and over here what is the width and what is the length, W and L value. Okay, so here, so this M stands for MOSFET, and this is the drain, gate, the source, and the body. So if we see this one, MOSFET, the MOSFET 2, MOSFET out is the drain, A is the gate, ground, the source, and this ground is the body. Similarly over here, and if you want to quit this window, then colon and WK. Now let's see the layout of a 2-input NOR gate that is drawn from the normal schematic. Open the terminal window by pressing Ctrl Alt T, then type magic, press enter. Now this is the terminal, this is the main layout, and this is the TKCon window. Then type grid in order to grid in, then press Z to zoom in. Now in our NOR gate, it is in the NOR gate, the PMOS are placed in series and the NMOS is placed in parallel. So in order to draw the PMOS, select the area. Since there will be two PMOS in series, so have to select larger area. Then type paint, anvil, now draw the P diffusion layer. Paint, P diff.
We can draw both the PMOS using one Lenvil and one P diffusion since they are in series. So now draw the two gates. Paint poly. Similarly, paint poly. Now, this is the source terminal. This is the source terminal of one PMOS. This is the drain terminal. This is source, this is the drain. This is source, this is drain. So the drain and source are shorted. So connect the source to the, we have to connect the source to the VDD layer. Type paint M1. So before connecting to VDD, draw the two NMOS. Paint and diff. So there are two N diffusion layers in parallel and diff. Okay. Now connect this to the VDD by metal layer. Type paint M1. Similarly, over here, the two source terminals of the NMOS is connected to ground. Now before that, we have to draw the poly layers. Select area, move up by 5. Now place the poly. paint poly. Now connect the gate of this PMOS with the gate of this NMOS. Paint poly. Paint poly. Now we have to connect this gate with this gate. So poly. Now erase this part. So this is the input A. Let us label it as A. This is input B. Label B. Now, so the VDD is connected now. The ground. Select the area. Paint M1. Now, this is the drain terminal. So save it as save. This is the NOR gate. So NOR 6. Then press enter. Now this is the drain terminal, and this is the drain terminal of both the NMOS. So short the drain terminal of the PMOS with this NMOS. Paint M1. Now short with this. Paint M1. Now these three terminals are shorted. Now this is the source terminal. It is from here to paint M1. Now label this as VDD. This is the ground. Now place the contacts. Select the area. Type paint PDC. Paint PDC. This is the end diffusion contact. Paint NDC. Paint NDC. Paint NDC. Now after placing the diffusion contacts, place the substrate contacts. Paint N substrate contact. Now similarly, along the N diffusion, place the P substrate contact. Now these are the two inputs and this is the output. So type paint Let's see the layout of a 2-input NOR gate from the normal schematic without using the commands. So first open the terminal window by pressing Ctrl Alt and T. Then type magic NOR 7.mag. So by typing magic NOR 7.mag, we are creating a new layout file. So this is the layout window. We will not type grid, we will press G from the keyboard, then Shift Z. If we will not use the commands, then we have to use the toolbar. So go to files, go to options, and then toolbar. You can see all the metal contacts, anvil, etc. So in order to draw the untwisted form, drawing from the untwisted form of schematic, first we have to draw the series PMOS. Select the area, then type paint anvil. We will not type paint, we will directly use from here. So anvil, this is P-well, this is anvil. So middle click on the mouse in order to select. Now select the area for P diffusion, then middle click on P diffusion layer. Now this is the end diffusion layer, so middle click on the end diffusion layer, then select the area, again middle click on the end diffusion layer. So this is the PMOS, these two are the NMOS. Now I have to draw the poly for the inputs. Select the area, then middle click on polysilicon, have to undo because there are two polysilicon layers. So this is one poly. Now since there are two polysilicon, we have to place two gates, we have to place two polysilicon. Undo. Now place the polysilicon over here also. So 4 gates are drawn. Now we have to short these two gates. Select the area, then middle click here. select the area, then double click. Then you have to connect from here. Then this is A, so type label A. This is B, type label B. Now this is connected to VDD. This is metal, so metal 1. Similarly, here the source of the NMOS is connected to VDD. Okay, now from here now this is VDD, and that was ground, and this is VDD. Now these three drains are shorted, so connect from here to here by metal 1, then from here to here. So the three drains are now shorted. The source is connected to VDD, so place a contact over here, select the area, and this is a P diffusion contact, that is PD contact. There's a PD contact, and over here there will be a N diffusion contact, so ND contact. Middle click, you should middle click in order to select any toolbar. ND contact. Now this is the output, these two are the input. We have to place some other contacts, that is the N substrate contact. This is the N substrate contact. Similarly, we have to place the P substrate contacts. P substrate contact. This is the output, so extend this. Type label Y. Type save, DRC find. So there are no DRC errors for NOR 7. Extract all.
extract to spice. Then exit. Type vi nor7 dot spice. So here the W by L ratio for both the PMOS and NMOS are same. There is a difference in the area of diffusion, perimeter of diffusion, area of substrate and perimeter of substrate. Now these are the capacitance, 6.6 farad. If you want to see my layout, type magic nor7 dot mag. So this is the layout. This is the whole layout of a 2-input NOR gate.